All right, so for this last one here, we have some equations. So as I stated before, if you could do a scalar multiplier of one to get the other, then you have infinitely many solutions. In other words, if I take this one and I multiply by 3, what's 3 times 2x? 6x. What's 3 times negative y? What's 3 times 4? 12. So system C, the graphs, so it says describe if the graphs in the equation, the graphs of the equations in each system are intersect, are parallel, or the same line. So we know that these are the same line. And they give us the graph too. So I'm verifying algebraically, but we could just kind of look at the graphs, right? So this is C. That's what we did here. These are both the same line. Now this one, this goes to this graph, and that intersects with one of these. Well, it intersects with both of them. It intersects with this one, right? So system B has one intersection. In other words, it's going to intersect here. So this one would be one intersection, or 1 point in common. Oops, I misspelled the word intersection. Intersection. Let me make this look more like a 1. That's a 1. Okay. And then that was system B, wasn't it? Dang it. I know. I told you at the very beginning of the school year, you guys got to write in pencil. So this is intersection. That's graph B. Now, what do you think by default the system A will be? Parallel lines. Now, trying to think of an easy way to say this. So if you think in terms, well, let's just look at it. Okay, so I've got 4x minus 2y. That's this one here. That's this equation here. That's this line, right? So that's that one. And then this equation here is 2x minus y, which is this one here, right? That's this line here. What do you notice about those two lines? They're parallel. So now, because they're parallel, they have no solutions. This one has one solution. This one has infinitely many solutions. I look bored with life? Why? Man, you guys keep judging me all the time. I'm not even sure how to respond. So intersecting lines have 1 point in common. Parallel lines have no points in common, and same lines have infinitely many points in common. System A has no points in common, or 0 points in common is another way to say it. 0 points in common, so it has no solution. System B has 1 point in common, so that point is the solution right here, which is what? What does that look like? 1, 5? Yeah? So that would be, let me get down here, 1, 5. And system C has infinitely many points in common. So it has many ordered pairs. Okay, that are on, if it's on the lines, and they make both equations true. And so lastly, and then I think we'll call it a day. for our first day back. It says, how do we solve each system and tell how many solutions the system has? I'm going to do one with you guys. I'm going to find the one that has the same line, which is infinitely many. So I'm looking for what we call as the scalar multiplier. I think it's this one, because if I take the second equation and oh wait, it's not that one. What's this times 2? It's this line. This times this is, oh, that's not it. I don't think I have any that are the same line. Oh, wait a minute. This is it over here. I found it. If I take this equation and I multiply it by -5, -5 times x is -5x, -5 times -3y is a positive 15y, -5 times 4 is a -20. So this one is the same line, so it has infinitely many. Many solutions. Now, the other thing that you could do, too, that's interesting, if you think in terms of ax plus by equals c, if both equations have a over b that are the same, then they are parallel. So, in other words, I have a 6 and a 2. So, if I say 6 over 2, and this is a 3 over a 1, isn't that equal to 3 over 1? I did that kind of quick. I want you guys to look at the board. I'm writing a bunch of stuff down, but look at the board. If I take 6 and divide it by 2, and then I take 3 and divide it by 1, aren't those the same? Yeah. So those are parallel lines. What do we know about parallel lines? No solutions. Now, what I've done is I've kind of figured out that they have the same slope. Technically, the slope, m, is equal to -a over b. So I technically would put this here, and that would be the same slope. Okay? So that has no solutions. And then by default, this last one has one solution. Now we could double check that. 6 divided by -2 does not equal 3 divided by 4. So it's not parallel, and they're not scalar multiples. So that means it's going to intersect. Does that make sense to you guys? Okay. So now I'm going to answer this last little tidbit here, and then I'll give you guys homework. We're not going to do homework today because I got to go over this example with first hour. First hour, we got off to a late start, so we'll have homework tomorrow that we could do in class. Okay. So it says, when you solve a system of equations algebraically, how can you tell what the system has 0, 1, or infinitely many solutions? Well, we wrote it in a general form, but let me explain. If I have 3 equals 3, that is a true statement. In other words, I go through and I do all the algebra and I get A equals A. I get the same number. 3 equals 3, 5 equals 5, 6 equals 6. Do you guys remember what that is? If it's a true statement, what does that mean? They're the same lines, so that means they have infinitely many. Have I been misspelling? Oh, no, I didn't. I have been misspelling infinitely all day today. Infinitely many. It's a funny story. Were you guys, was it this class or the other class where I spelled infinitely? I did like one too many I's. Was that you guys or the other class? So anyways, this is how you spell infinitely many. I don't know why I keep spelling it this way, but I noticed that earlier today, and I was like, I gotta fix it. And in my brain, you can INF if that's how you want to do your notes. Now, if I get 5 equals 7, that is a false statement. 5 will never equal 7. And what I mean by that is if you get 7 equals 3 or something that equals something but they don't really equal, that's a false statement. So that means that they are parallel, and that means that there are no solutions. If you get x equals some number, 3, one solution. If you go through and algebraically solve it and you get y equals 0, one solution. Okay? So the general form that we did before was A equals A. Whoops, not A equals B. Goofy. All right, so that's A equals A. And in all these scenarios, A cannot equal B. If you get A cannot equal B, you have A equals B, but they don't equal. That's not true. And then, so it's no solution. And then if you get X equals A or Y equals lowercase b, then you have one solution where they intersect. Any questions on that? All right, we got like a minute or two left. So what I'd like for you guys to do is you can put your calculators away, but go right back to your assigned seats, pick up your mess around you, but stay in your assigned seats until the bell rings, please.